Good morning, everyone. First of all, I would like to thank the organizing committee and the honorable assistants. I am Meryem Hdidou, a PhD student at the International Water Research Institute at UM6P, and today I will be sharing with you my research findings about the usage, functionality and benefits of construct wetlands with the purpose of treating wastewater and reusing it in agricultural irrigation. For this, my presentation will be outlined as follows. First, I will define the background and problematic. After that, I will present the methodology adopted in this work, and I will briefly present the results, including the construct wetlands classification and components, and I will conclude with the potential use of construct wetlands for wastewater treatment and reuse in Morocco. The planet is currently facing the rising issue of water scarcity, notably in arid and semi-arid regions such as Morocco. Population growth, economic and industrial development, and climate changes all contribute to the increasing pressure on water resources. Moreover, agriculture consumes more than 86% of available fresh water, as shown in this graph. To address this situation, wastewater use was among the alternatives strongly suggested by the National Water Plan and the National Plan for Reuse as non-conventional water resource. However, the level of wastewater use is still low due to several constraints. Furthermore, the reuse of wastewater in irrigation has several benefits, but also some drawbacks due to the presence of undesirable contaminants. This is why the quality of water must be controlled and reliable treatment must be provided to meet the standards and regulation for wastewater use in agriculture. Therefore, several treatment technologies are available, but they require intensive energy with high operational and investment costs, which is not appropriate in developing countries. This is why construct wetlands can be investigated as an alternative technology for wastewater treatment and reuse, especially in rural areas. So the objective of this work is to provide an overview of the treatment performances of constructed wetlands and to investigate the effects of the different components on their efficiency in order to assess the potential of constructed wetlands for application in rural sanitation and wastewater use in agricultural irrigation in Morocco. For this purpose, data was collected by conducting researches on the scientific databases ScienceDirect and the Web of Science, among other sources, using a combination of keywords. Eventually, 29 research articles were analyzed covering 16 countries and different types of wastewater. A summary of the studies, including the type of construct wetlands, design parameters, and operational parameters, as well as the removal efficiencies, were presented and analyzed. So let's start by defining what is construct wetlands. Construct wetlands is a nature-based solution designed to treat wastewater through different natural processes using the combined action of plants, substrates, and microorganisms. They are efficient, cost-effective, and eco-friendly and energy-saving. Different designs of construct wetlands exist, including free water surface construct wetlands, which represent flooded and planted lagoons characterized by good removal efficiency of organic matter and microbial contamination, but also a large footprint and a high evapotranspiration, which makes them unsuitable for use as a wastewater treatment system for agricultural reuse. There is also horizontal subsurface construct wetlands where the wastewater flows horizontally beneath the surface. In these systems, the anaerobic conditions are predominant and the organic matter, expanded solids, microbial contamination, and heavy metals can all be removed very effectively. On the other hand, vertical subsurface constructed wetlands represent bed, field, with layers of substrate in which the wastewater flows vertically. And in terms of treatment efficiency, vertical constructed wetlands outperform the previous configuration with high oxygen transfer favorable for nitrification and aerobic degradation. Hybrid constructed wetland, and finally hybrid constructed wetland that combine different types of constructed wetlands to exploit their different advantages, and effectively hybrid constructed wetlands can achieve high performances in the elimination of conventional wastewater parameters as well as emerging pollutants and microbial contamination. To ensure a sustainable constructed wetland system and to maintain a long-term treatment performance, several parameters must be taken into consideration, including the selection of substrate and vegetation along with operational parameters. Indeed, substrate plays a major role in pollutants elimination, and to choose the appropriate material, several criteria should be considered, including the local availability and cost, physical, chemical, and biological properties. Vegetation is also very beneficial for wastewater treatment since it contributes to the elimination of different pollutants and to the transfer of oxygen from the atmosphere to the beds. However, vegetation associated with high temperature could accentuate evapotranspiration, which is not beneficial for wastewater use. And finally, microorganisms that contribute to the elimination of different contaminants through the assimilation, transformation, and recycling of pollutants. The microbial community is in fact affected by the substrate and vegetation. So to conclude, in Morocco, the National Water Plan and the National Plan for Reuse promote the reuse of treated wastewater and aim to increase their usage to 325 million meter cube per year by 2030. Although wastewater use in agriculture has several benefits, it may generate a negative impact on soil, groundwater quality, and human health due to the presence of some contaminants. Therefore, the water quality must be controlled and an appropriate treatment must be considered in order to obtain effluents. Conventional wastewater treatments can generate good quality effluents, but they require intensive energy and high operational and maintenance costs, making them unsuitable for developing countries. And in the light of different studies analyzed in this work, constructed wetlands can be regarded as promising alternative for wastewater treatment, regarding of the variability in performance that different designs may provide. Indeed, they can produce a good quality effluent with a high removal efficiency of different contaminants, including heavy metals, pathogens, and micropollutants. For this reason, the use of constructed wetland as treatment technology in Morocco has yet to be developed. For further information, you can check our review paper entitled Potential Use of Constructed Wetland System for Rural Sanitation and Wastewater Use in Agriculture in the Moroccan Context, published in Energy's Journal. And thank you for your attention.